This video is brought to you by our amazing supporters over at Patreon. Hey everyone, it's Ben from Board to Bits, and this is just a quick video. I wanted to show something I've been working on over the past week that is just a simple kind of visual technique to give things like menus or other kind of lighter spaces in your game a little bit more visual interest. And like I say, this is a very kind of a simple thing, but it's handy because it allows you to, especially if you're working on something like a prototype and you don't really know what your main menu is going to look like yet, but you want it to have a little bit more visual polish than just kind of having, if you just had, you know, the words on a blank screen, which is fine, but it'd be nice if you could give it just a little bit more visual interest, and this is a way to do that. It makes it a little more dynamic, especially something like your main menu, where if you've got playtesters and stuff, they're going to be coming to this every time they play. Just makes it a little bit more interesting for them. And so basically what I did here was I added a mesh object, and I kind of created this one. It's abstracted a little bit, low poly, but you could certainly use even something as simple as a prop from your game if you're working in 3D, or you could even use just something abstract. In fact, when we get into the demonstration, I'll probably just make something abstract with some primitives, but you can really put any object you want in the background, and that in and of itself adds a little bit of interest. But then what I did was I added a little script to this so that when we hit play and we start moving the mouse around, you get this little bit of motion. You get a little bit of motion here based on where your mouse is. And so it's nothing major. It's not actually affecting anything in the game. It's not affecting the UI at all. But it just, like I say, gives just that little bit more dynamic feel, gives a little bit extra sense of polish, so that even if you're just working in a prototype, you can quickly throw this on. You're not really distracting from your development of your game, but it just kind of takes your game up a little bit of a notch right from the get-go. So now that you see how this is working here, basically wherever I am positioning the mouse, the object is rotating to follow, and it's kind of assuming this idea that like down here is a kind of 0, 0 point for the mouse, and then up here is 1, 1. Kind of I'm normalizing the position of the mouse, which is going to be important when we see how I'm kind of rotating this in the next couple minutes. So with all that said, let's jump over to a fresh project and get this started. Okay, so now we have a fresh scene here with no scripts or anything yet. We've just got our main camera, which is currently I've got on an orthographic setting, but this will also certainly work with the perspective view instead. You do want to make sure you have a directional light just so that you have, especially if you're working in a 2D game, so that your 3D meshes can get some kind of light on them and they're not just kind of a flat black image in your background. And then I really just created a few primitives here and applied some basic materials to them. You can, like I say, do whatever you want, add your own props, add something abstract, just as long as you make sure that everything is ultimately parented to a single object, because you're going to want this to be able to rotate as one single unit. So with that, we're actually going to add one more thing here. If you notice, my cube has a rotation kind of set to it of about 15 degrees on its X and its Y axes. And that would actually kind of impact how this rotates, because that means that our axes are technically, if I go to the local view of the axes, you see that they're kind of on these weird angles, which depending on how far you've rotated them could really impact how this whole system works. So I'm going to create a game object. I'm going to create an empty game object. I'm going to just call this pivot. And I'm going to quickly go back to that parent cube, and I'm going to, its position is just 0, 0, 0, but were it something different, I would want to copy those values and probably put them into the pivot so that it's sharing the position of it. In fact, actually, we see that my pivot is not at the same position. So I'm going to make sure that this is at 0, 0, 0. And so it's kind of sharing that same position, but its rotation is more specifically at 0, 0, 0 in this case, so that the local axes are perfectly straight up and down for the y-axis and perfectly left to right from the camera's perspective for the x-axis. And now I'm going to make this cube a child of the pivot. And this pivot is actually what we're going to apply our reactive rotation script to. The last thing you're going to want to do before we create that script, though, is you're going to want to, this is really kind of more effective if it's really zoomed in and kind of close. So I am going to do that now. Now, with a perspective camera, you can do this by simply bringing the camera much closer to the object, and you don't have to worry about how close you get because any UI you have is going to overlay over the camera anyway. For the case of a orthographic camera, though, there is no really zooming in. Everything looks the same size no matter how close or far you are to it. Instead, what we do is we affect this size here of the orthographic camera. So I'm going to bring that down so it really kind of zooms in pretty close on these objects. And I'm also going to actually move the camera a little bit just so it's not just not quite so off center of all these objects. So I'm going to move it up a little bit here and maybe to the left a little. So something like that should work. Maybe even down a little bit further just so it's kind of focusing on that one. And I might bring this sphere down a little too. This is obviously going to, this is just kind of eyeballing it depending on the stuff that you're working with. But something like that should work fine for this purpose. Now we can create our reactive rotation script. So I'm going to go down here and create new C# script. I'll call it reactive rotate. And we'll open that up in MonoDevelop. Let me zoom in a little bit here so you can see what I'm working on. And we're going to keep this as a mono behavior. And we are actually going to keep both our start and update functions for this script, because we're going to be using them both to set some variables and then obviously to react to the mouse moving. But there's also going to be a few variables that we need to add in here first. And the first thing I'm going to do is going to create a public vector2 called angle range. And this is really going to tell how far that our meshes are going to rotate depending on if we're at the extreme ends of the screen. And this doesn't have to be a lot. We really want this to be more of a subtle effect because it's not a focus, it's the background thing happening here. So I found that about 4 degrees is all you really need. So we'll create a new vector2 with just 4 plugged in as the x and y values. Now, we're making this public, so we can certainly adjust this as we need to in the inspector, but I just kind of like having that starting value so that there's something there to work with, and like I say, 4 feels pretty good. The other thing I'm going to create are 2 public bools. The first one's going to be called inverse x and inverse y. And these are simply going to be, depending on where you put that pivot, like we put it right now right in the center of our mesh, but there are situations where you might want it to be somewhere different from the mesh. In fact, you can get some really cool effects by placing it kind of in between your mesh and your camera, and I'll show that at the end of this video. But when you do that, though, you may want the axes that you're rotating on to be inverted to have for a little bit better feel. And so putting those in there just kind of gives us that option to edit that on the fly. Lastly, we're going to have 2 private variables. The first one is vector2 mouse position. And that's just going to hold that information for us rather than having to create that vector2 every single frame. And then a vector2 called base rotation. And this is going to store right from our start method the sort of baseline of what we're rotating from. In fact, we can jump into the start method right now and create that. And so we're going to set base, on start, we're going to set base rotation equal to a new vector2. And we're going to need to get our transform rotation dot Euler angles because rotations come in quaternions and we need to switch this over so we can get into an XYZ format. .x, and then I'm actually going to subtract the angle range .x times half. And the reason for that is that I don't want this to be at its base rotation when I'm down in that bottom left, this kind of 0, 0 corner. I want it to be at our base rotation right where we're in the middle, because we're going to kind of be adjusting our rotation of this mesh and stuff based on based on it kind of being in that center view. We don't want to kind of suddenly snap into something that maybe not be the ideal angle as its kind of baseline. And then we're also going to set our y to pretty much the same thing, but just with y. So transform.rotation, I guess that's going to snap back on me with auto formatting, dot Euler angles dot y minus angle range dot y times 0.5f. So again, that will kind of be, that centers it so that when it appears on screen, it's centered based on the mouse being right in the middle of the screen. And that's all we need to do in our start method. Now we can go to the update method, and what we're doing here is we're going to quickly check for what the mouse's current position is, and then adjust our rotation based on the base rotation plus our angle range. So first thing we need to do is get that mouse rotation or mouse position. So we'll say mouse position equals a new vector 2, which is input dot mouse position dot x, and then we need to divide that by our screen width, because when we get input.mouse position.x, that's actually giving us the pixel position on screen, which can change from screen to screen, which is one issue. And the other issue is that it's going to, chances are, be a large number in the hundreds or possibly even thousands. And so we don't want to be rotating this, by magnitudes of 1,000. We want it to be rotating it between, like I say, a normalized value of 0 and 1. So by dividing that pixel position by the total pixels in width, we get that. We're going to get a value between 0 and 1. Likewise, we want our our y position to be mouse position dot y divided by screen dot height. From here, we can calculate what we need the rotation to be on the x and y axes. And there's a little bit of a gotcha here, because I'm going to create a float x rotation. And when you think about the x rotation, I'm talking about the rotation based on the x-axis itself. And we might think, oh, I want the x position of the mouse. But you really don't, because when you think about it, the x rotation is actually on, if you could imagine an axle going from left to right, when that rotates, it's actually going to be kind of visually moving the object up and down on our screen. Kind of as if you were facing a wheel head on, you would kind of just see the wheels rotating, like what's ever at the top of the wheel then coming down in front of you and then going to the bottom of the wheel and then back up around. So it's really an up and down motion. So if you were to base the x rotation on your mouse's horizontal movement, it would feel very weird. What we want instead is to actually look at the mouse's vertical movement. So we'll say mousepause.y times our angle range, times our angle range, and this can be .x, because we're going to kind of assume here that this x and y are referring to the axes themselves. And likewise, our actual base rotation is again assuming the x-axis, so we'll say base rotation.x. And we can do the same thing for the y. We'll say y rotation equals, but here we're going to say mousepause.x, because again now we're rotating on kind of like the Earth's north to south pole, which is kind of rotating left to right or right to left. So we want our horizontal position of our mouse here, times angle range dot y plus base rotation dot y. And then finally, all we have to do is say transform dot local rotation equals quaternion dot Euler, because we're going to be converting our vector 3, or we'll make right here, into an Euler, or into a quaternion rather. And so we'll say new vector 3 x rotation y rotation. And that's really all we need to do. We can jump back over to Unity, and we will apply this, like I say, to our pivot. So I'll say add component, reactive rotate, and then we hit play here. And now we see that as I'm moving my mouse around, we have this, again, very subtle, but it is this motion that kind of gives us a little bit of a feeling that something's going on. Like if there were buttons here and that, you could be doing this and you would get this little bit of a motion that just gives you a sense that there's more substance there than just a blank screen. Now, like I said, this is all working right now with it kind of rotating based on the center of this particular mesh here. What can be a very cool effect, though, is if we pull this, I'm going to kind of deparent this for a second so that I can move the pivot without moving the meshes around. I'll focus in here a bit. Let me break out of 2D for a second. And if I bring this sort of out to here, like right in between the meshes and the camera, and then I reparent this, now when we rotate, we're going to be seeing it rotate kind of up and down. It's going to be a little bit more motion to it in addition to rotation, because it's almost as if this is on the edge of a big globe that's being rotated around. So now when I hit play, what we'll see is we get a lot more motion here. But there's also this kind of, like I say, this weird thing now that when I move right to left, it moves along, it moves with it, so to speak, where it's moving moving the mouse right moves all the objects right and left, which in a weird way feels a little bit wrong. And I think it's because we're kind of, like I said before, it's like we're on the inside of a globe and looking out at it, and it just kind of feels like it's moving. I can't even really explain it fully, but it doesn't feel quite right. And so well, that's why we added these inverse X and Y's up here, so that we can say, hey, I don't really want the inverse to be moving in that particular manner, so I want to like inverse my X rotation here instead. And how we're going to do that, because right now, unfortunately, if I do that, I can hit inverse X, but it's not going to do anything. We're still moving left and right together. And that's because we never applied anything in our script. So let's jump back over to MonoDevelop. And what we're going to do is, instead of just automatically saying, oh, we just want the mouse position X, we want to check and say, oh, well, if we're doing inverse of X, then what we want instead of mouse position is really 1 minus the mouse position, which is so that instead of saying we're assuming we're at 0.1, we're actually at 0.0, or instead of being at 0.75, we're actually at 0.25. So it gives us the opposite effect of motion. And so we can do this with just a simple conditional check here. And we'll say, so instead of saying just mouse position.y, we'll say, I'm going to kind of put this all in here and then I'll crop this out after. We're going to say inverse X, kind of asking the question, is inverse X, is it true? And this is, MonoDevelop's not going to like how I framed this right now, but that's okay. If it is inverse X, then we want 1 minus mouse position.y. Otherwise, if it's not inverted, then we just want the raw mouse position.y. And then, just like that, again, we're just going to simply multiply that by the angle range and the base rotation. And while we're at it here, we can do the same thing to our y rotation. We're just going to make it inverse y and checking, and then doing 1 minus the mouse position.x, or just simply mouse position.x. And with that, now we have the ability to check off this inverse.x rotation, and when we hit play, well, now we're just matching up both. That's a little bit weird. That should be the other way around now. If I hit, I guess now if I hit inverse.y. Why is that doing that way? Oh, because I switched once again, like I say, it's a little bit of a gotcha here because of the fact that we're looking at our mouse position versus our actual rotation axes. And so these should be switched. This should be, if you want inverse Y, it's based on the mouse's position, and inverse X. I think it's a little bit more logical to think of it that way, or a little bit more inherent, I guess. So yeah, we'll switch it around that way, and now we can say inverse.x, and now it rotates properly. So because we have inverse.x here, this is saying inverse of the X mouse position. And so now we see that it rotates when I move the mouse to the right, we move to the left, and when I move the mouse to the left, we move to the right. So it's got, like I say again, that just a little bit better feel. It feels a little bit more spatially correct. But really, with all that put in there, now you have this very simple, but again, a little bit more immersive way that when you're just in a menu, or it's, you know, simply working in the background, it's kind of doing this thing, and it feels like there's a little bit more dynamicness to your game versus it just being a flat screen. So I hope you find this useful. You're able to kind of throw it into a menu somewhere, and it gives a little punch to your game. And in the meantime, thanks for watching, and I'll see you guys next time.